Today I'm in the Big Apple meeting with Josh Gordon from Google to talk about machine learning, where we will dig into how it works, why it's important, and where you can learn all about it. Welcome to Coffee with a Googler in New York City. I'm Lawrence Moroney, and I'm here today speaking with Joshua Gordon. Now, it's something that a lot of people don't really understand what machine learning is in a concrete manner.
So machine learning is all about learning from examples rather than writing manual rules.
Got it.
So the short way of saying that is regular programming is you write a lot of manual rules to solve a problem. And in machine learning, you let the algorithm find those rules for you.
Got it.
From examples.
So pattern matching, it might be visual, or it might be like other patterns that are hidden in data.
Absolutely. And so the input to machine, so the beauty of machine learning and like the real secret sauce is that an algorithm that learns patterns from data can solve thousands of different problems. And the reason is, if I write a Python program to recognize digits, my program is hard-coded to work with digits.
Got it.
But if I write an algorithm to learn patterns from data,
right,
I can use that for speech recognition, image recognition, medicine, basically anything that you can start with examples. Just tell apart A and B. My same algorithm that I wrote just once can tackle all these problems. And that's a really special and actually fairly profound thing.
Absolutely.
Yeah.
Now, one of the things in your class is that you're talking about that you're starting with language, right? You're starting with Java and Python, I think it was that you said.
Yes, absolutely.
So how is the class going to be structured for people who want to be these data scientists?
Absolutely. So first of all, there are 0 prerequisites. Well, that's not true. There's one prerequisite.
My favorite.
Yeah.
Oh, okay.
Well,
what's the one prerequisite?
Basic programming ability
in
Java or Python.
Okay.
And by basic, I mean like you can run scripts and you can tweak them.
Okay.
That's it.
Cool.
A little bit of high school math, and that means like basic algebra, basic geometry. When I say basic geometry, like to be totally honest, if you ask me like what's sine and cosine, like I would have to Google it. I don't remember, honestly. So just basic familiarity, and that's it. And we're going to teach the class in 3 ways. We're going to teach it totally from the ground up. So one problem I had with some of the academic classes I took is that they'll talk about a fancy algorithm like neural networks, but they'll talk about it in terms of math. And so at the end of the class, I don't know how to build that. I can't really do it. We're doing it in the reverse way. We're building it step by step, and we're explaining only the math that's really necessary as we go. And instead of equations, we're going to use visual examples.
Perfect.
So an equation could be like, if you talk about gradient descent. Gradient descent basically means finding the minimum of a function. So if I just say that, like as a developer, I'm like, all right, like what does that mean? So you can think of like any equation, like x cubed plus y squared plus whatever equals 7. There's some value of x and y.
That's going to be the bottom of that curve.
Or not equals 7, like equals some value, right?
Yep.
Anyway, you can find the bottom of that curve literally by thinking as a bowl. You can like drop a piece of like fruit in a bowl and it will roll to the bottom. And like gradient descent just means finding like where this function is 0. And like you can actually describe that really simply in like only like 10 or 12 lines of Python actually. Instead of like 5 slides of equations.
And I think it's also important to understand why you need to find the bottom of the curve in that kind
Absolutely.
of thing. And just focus on that example.
Absolutely. So that's difficult to describe concisely. So oftentimes, so in machine learning, let's say you're writing an algorithm let's say it's to distinguish apples from oranges, right? You always want to know how accurate is my algorithm. Like, I can solve that problem in 1 line. I can just say return, math.random. And then, so like 1 line, math.random.
That'd be the perfect one, right?
And my accuracy is crap.
50%.
Right. Yeah, it's 50%, right?
Between an apple and an orange.
It's a one-liner.
Yeah.
Right, but really we want to get, another way of describing accuracy is you can think about it in terms of error. Like high accuracy means low error. And you can have an equation that describes your error. And the minimum of that equation is going to give you the highest accuracy. So you can write your machine learning algorithm to try and minimize the equation that describes the error. And like we'll make that super concrete in the class. But that's where minimization comes in, and that's where gradient descent comes in.
Now, so one of the things you're saying in the class, you're teaching just a pure Java, Python version, but there's also a version where you're bringing in pre-existing libraries that have come from academia that will solve a lot of this for you, right?
Absolutely. So I want to do a couple things. One is I want to provide the TLDR. So like, honestly, like as a developer, I like to get up and running really fast. So we're also going to use open source libraries from just different universities. There's one in New Zealand that I really love. We're going to show you how to build. So basically, first, everything from the ground up, step by step from scratch. And the reason we do that is because it keeps us honest. If you build every single piece, you have some understanding of every single piece.
And if you're relying on somebody else having done the work, you don't fully get to understand it yourself.
Exactly. Now another thing is using the open source libraries, honestly, you can solve probably 80 or 90% of the machine learning problems you would like as a data scientist. Now, when you get to the really gigantic problems, then really it makes sense to use the cloud. So we're also going to teach how to solve problems using Google APIs, but that's at the very end of the class, and it's totally optional. This is
all
all
on YouTube,
all
right?
on YouTube.
Okay.
There might be some ads on it, but that's literally it. We think it's going to be awesome.
Like source code and stuff that you've done.
The source code will be on GitHub.
It's all
It'll
on
all
GitHub.
be on GitHub.
Perfect.
And the reason I was hesitating is I'm writing all this as we're speaking, and so like I'm totally exhausted, but
Yeah.
it's totally 100% out there.
Well, you're still looking energetic to me, so
I've had a lot of coffee with a Googler.
Good for you.
So like, yeah.
Well, yeah, I for one am really looking forward to this course. I'm looking
Excellent.
forward to learning what you have to teach. I've had the same kind of struggles as you in trying to understand the math behind this and why I'm doing the math, which is why I had those pointed questions earlier. So,
Absolutely.
So thanks, Josh. That was a whole lot of fun, and I've learned so much about machine learning just from these few minutes with you. So I'm really looking forward to your class.
Thanks so much.
If you've enjoyed this episode of Coffee with a Googler, and if you want to learn machine learning for yourself, if you have any questions for Joshua, if you have any questions for me, please leave them in the comments below. And tune into the Google Developers channel for more great videos, including episodes of Coffee with a Googler. Thank you.
You really can learn machine learning, and it's faster and easier than you think. We've gone through a ton of classes, textbooks, and blog posts to bring you the clearest and most concise explanations of the hard concepts. We really think you're going to be able to learn it and have some fun on the way. Click here to get started.